Good evening. Hello everyone. Hello. Am I audible? Hope all of you can hear me. This session I'll be discussing whole of differentiation, which is included in your class 12 syllabus, and after this session your revision work on differentiation will be completed. I am starting from differentiability of function, then I will show you first order differentiation and then second order differentiation. Although those are direct differentiations, but you need to revise the concept before you start solving PYQs or board sample papers. So this session I will remind you whole of differentiation from beginning. Okay, may not be very difficult sums we are going to solve, but this session definitely will help you to master the topic, to restart, to revise it. Okay, let us start without wasting time. The topic is differentiability of the function, of a function. I will be discussing the meaning of differentiability at a point. Meaning of differentiability is just to check whether dy by dx equal to limit h tending to 0 f of x plus h minus fx by h exist or not. Okay, and this one geometrically this represent, if I have taken the function y equal to fx and y plus delta y, f of x plus delta x, then you know delta y is f of x plus delta x minus fx, and here in place of h we are writing delta x, so this can be written as limit delta x tending to 0 delta y by delta x also, not dx. This is delta y by delta x, and that only we write as dy by dx. So this dy by dx geometrically dy by dx is slope of tangent. So by checking whether it is differentiable or not, we are going to check for what? That we are going to check differentiability of a function. We are going to check differentiability of a function. This implies to check whether a function has well-defined tangent at a point or not. Whether a function has a well-defined tangent at a point or not. What does it mean? Well-defined means this tangent should be unique. It exists, tangent exists, and it should be unique. Tangent exists and this tangent should be unique. If tangent is not unique, then the value of dy by dx, you are getting two values. Two values not possible. You will get one value of this limit only. It means on it, if you are going to find the left hand limit, the right hand limit, which ensures the condition of existence of limit, and those limits are equal, then we say that function is differentiable or function has unique tangent. So for existence of dy by dx, the above limit should exist. Before we proceed, I hope all of you are practicing with me. If you don't practice with me, this session is not useful. But if you practice with me, I am going extremely slow speed, not moving very fast. And differentiation, you are not new to this topic. You have done it before. You are revising the concept of whole of differentiation in this one class. So be serious and do it with me. Otherwise, it's of no use. For existence of dy dx, the above limit should exist. That is, what does it mean? That left hand derivative must be equal to right hand derivative. So this implies limit h tending to 0 minus, or you write this way, limit h tending to 0 f of x minus h minus fx by minus h, and this is limit h tending to 0 f of x plus h minus fx by h. Okay, so these two limits must exist. They must equal, then only function will be differentiable. Geometrically, I showed you in previous classes, this will represent the slope of tangent from left side of the point x. The point may be a. You replace x by a. Then limit h tending to 0 f of a minus h minus fa by h should be limit f of a plus h minus fa by h. It means slope of tangent from left hand side. This is slope of tangent from left hand side of the point A. This is slope of tangent from right side of the point A. They are equal, they coincide, then only function is differentiable. Okay. So let me draw a few functions and check whether it is differentiable at the point or not. Just I am drawing this curve. Let us start with the easiest one. This is the graph of a function. This function is not differentiable at x equal to 0. Why? From left side of 0, if you proceed, this is the graph of the function y equal to minus x, and this portion is y equal to x. I hope you all recognize function is y equal to mod x. At x equal to 0, the function is not differentiable. Why not differentiable? Because from left hand side, if you approach the point 0, the slope of tangent is minus 1. This one makes 135 degree, it is minus 1. slope of tangent just after 0 is 1 and they don't coincide. So what will be your idea? This function is not differentiable at x equal to 0. Already I have explained. Let us take another example. Which is on mod function only. X minus 1 plus x plus 2. Okay. This kind of function I refer as boat function, because when you are plotting, then the function will take the shape of a boat. Okay. If you take mode functions like this, if you add them, you will realize the boat properly. So for a boat function like this, if you plot the graph almost going to be like this: -2, 1. If you plot the graph, shape of the graph will be like this. Okay, this function is not differentiable at -2 and at 1. Why not differentiable? Because I am just discussing the geometrical part. Analytically I will show you definitely. At x equal to -2 and x equal to 1, tangents are not unique at both the points. So conclusion will be what? We are getting different value of dy by dx. So conclusion will be the function is not differentiable at x equal to -2 and x equal to 1, because you don't get unique tangent. Any curve at a point, if you get unique tangent, then only it will be differentiable. If two tangents exist, then it will not be differentiable. Got the point? We'll be discussing with more, but some analytical problem let us start with. Suppose we are given a function f(x) equal to, say, 1 minus x for x less than 1, and this is equal to x square minus 3x plus 2 x greater than or equal to 1, and you check differentiability at x equal to 1. You need to check differentiability at x equal to 1. Definitely when you are answering MCQ question, you have every right to check it by drawing graph. If you plot the graph, this part is going to be a straight line and this part going to be a parabola. You will not get unique tangent at 1, I guess, but let us see, let us prove it. You may get, and this time I am not going to check graphically, I am going to check analytically. So what we will do it here? If this is a board question given, I mean descriptive part, not MCQ part, you will always start this manner. Here f dash 1 is what? Limit h tending to 0 minus f1 by h. Then we will find L f dash 1. This is f of 1 minus h, f1 by minus h, and what is r f dash 1? The same manner you can write r f dash 1 will be, this will be plus h only, f1 by h. This one, when you are going to evaluate the left hand derivative at 1 minus h is this part, so I will be taking the function at this part. How will I get f of 1 minus h? Just use this part of the function, because 1 minus h is less than 1, so this will be 1 minus h. This is h. For f1, what will you do? Equal to 1 given here, so we will be using this part. So this part is also 0. This will be limit h tending to 0, h minus 0 by minus h. Value is minus 1. Isn't it? Left hand derivative you got minus 1. Right hand derivative, let us find it. This will be f of 1 plus h. For f of 1 plus h, I will be using this part because x greater than or equal to 1. Am I correct? fx is, this part is defined for x greater than 1 equal to 1 also. 1 plus h is a quantity which is greater than 1. So, we have to evaluate that part. This is going to be 1 plus h whole square. So, this is 1 plus 2h h square. So, answer will be h square minus h, isn't it? We'll just put it there. So this you write h square. If I am going very fast, you must text me. You can, yes, better you text me, then I'll go very slow. Now, for x equal to 1, we have already calculated, it is 0. This by h. So, it is limit h tending to 0, take h as common, this by h. Now, h get cancelled from numerator and denominator. Okay, so here this is going to be minus 1. Clear? The value is minus 1. So what do you observe? They have the same limits, minus 1, minus 1. As they have the same limit, so unique tangent exists. You can, for MCQ question, suppose in board also you are going to plot this graph and check very fast for MCQ. And similar approach is true for solving problems in entrance exam. We need to plot this graph. It's not a difficult one to plot the graph. You can plot this graph easily. Just the point, you take 1 over there, and before 1 the slope is minus 1. The graph, because it is less than 1 now, so we will be taking the graph this manner. Its slope is minus 1. Wait a minute, just a minute. This graph obviously a straight line graph, just less than minus 1. Okay, this is the line fx equal to y equal to 1 minus x. For x equal to 0 it is 1, so passing through 0, 1, and just before 1 it stops. And here for x equal to 1, this is parabola, fx or y equal to x square minus 3x plus 2. This you can write as x minus 3 by 2 whole square minus 1 by 4. So x minus 3 by 2 whole square is y minus 1 by 4. So it is 3 by 2 comma minus 1 by 4. And for x equal to 1, it has value 0. So this graph will be pointing upward. 3 by 2 comma minus 1 by 4 is the vertex. It will be pointing upward over there. Okay, and it will lie just after the point 1. The graph is 3 by 2 point somewhere like this, minus 1 by 4 somewhere like this. Okay, just if you start plotting it, the graph of function going to be almost like this. You can see that at this point x equal to 1 comma 0, this graph coincide with the line, at least at the neighborhood of the point x equal to 1. The graph of y equal to x square minus 3x plus 2 and y equal to 1 minus x, these two coincides. Okay, so we get unique tangent over there. Beyond the point 1, before it, after it, it will change definitely. But at this point, it seems that the graph coincides with the line. Understand the meaning of differentiability problems? You will get lot many. But this geometric interpretation of any function, you should practice. I will give you many sums to practice, to check graphically and analytically whether a function differentiable at a point or not. Once more I would like to tell you, just differentiability in an interval means the function will be differentiable at every point inside the interval. And those polynomial functions, exponential functions, trigonometric function, no, polynomial and exponential, they are everywhere differentiable. And if two functions are differentiable, their sum, their product also differentiable, but quotient may not be quotient possible if the denominator part is not equal to 0. fx and gx be two functions, their sum is differentiable everywhere. If they are separately differentiable, their product, their quotient also fx by gx, provided gx not equal to 0. This you have done before, you have done sums, we are revising it today, that's why I have taken this sum for revision purpose. Okay. Now, suppose, let us do one more sum on differentiability. I just remind you the concept because most of you forget the concept of differentiability and most of you don't like, or you like most. I like most this topic. Probably some of you like it most. So let us see how much you like it to solve this sum. fx equal to 1 by x sin x square. Just one more sum to remind you. X not equal to 0, equal to 0 when x equal to 0. They asked me to check differentiability at x equal to 0. How will we check? We can check it this manner. This time function is not defined for less than 0 or greater than 0 separately. It is defined for as a whole x not equal to 0. Isn't it? So, you will be just checking whether we just check whether limit x tending to 0 1 by x sin x square exists or not. Okay, sorry, extremely sorry. On this function we just check fx minus f0 by x, or you take, since the point is 0, just modify the definition. In place of a you take 0 and h, fh minus f0 by h. Why I am taking this way? Because f dash a, if I remind you, it is limit h tending to 0 f of a plus h minus fa by h. I have just replaced a by 0. H is there. So if this one exists, then it will be differentiable. Unique tangent is possible. No need to calculate the left hand derivative and the right hand derivative separately. So let us find it. This is going to be fh sin h square. f0 is what? 0 they have given. Don't hesitate. This is limit sin h square by h square. Now as h tending to 0 implies h square tending to 0, so this is going to be 1. It's a finite quantity. So derivative of the function exists and the value of derivative of the function is equal to, value of derivative of the function is equal to 1. Slope of tangent is equal to 1. Okay. Now let us solve another type of sum where differentiability in an interval is involved. Although I have done many sessions based on it, but this time I am just going to take a different type of example to remind you the concept. Suppose a function given this manner, fx equal to x less than equal to 1, ax square plus bx, x greater than 1. It is differentiable everywhere. Then show that given this function is differentiable everywhere. Show that f dash 3 is equal to minus 10. We need to check only this thing. This is differentiable everywhere. Show that f dash 3 equal to minus 10. Concept is there. I told you differentiability everywhere means it is differentiable on R, the number line. It is differentiable at x equal to 1 also, isn't it? So for this function you need to get the values of a and b. Then you need to find derivative at x equal to 3. That is possible if and only if you got a and b and then differentiate this part directly to get the value of f dash 3. Because 3 is much greater than 1. In this subject, on the number line, you just say that there are 2 steps. But there are infinitely many points in between. I am talking this sense only. So to find f dash 3, I need to get the value of fx for x greater than 1. That is possible when I find the values of a and b. So what you have to do there? You have to get a and b first. And differentiability property is that if a function differentiable, it must be continuous there. Okay, today I will remain silent. If it is not essential, I will remain silent about continuity. I will be solving the sum with the help of differentiability only. Okay, this function differentiable everywhere. So answering this manner, the function must be differentiable at x equal to 1 also. This function must be differentiable at x equal to 1 also. So limit h tending to 0, remember it, left hand limit at 1 by minus h should be equal to limit h tending to 0, this divided by h. 1 minus h is less than 1, less than 1 is this part, just put 2 into 1 minus h plus 3. If one I have to put there only, because equal to 1 also it is defined. 2 into 1, not 2x, 2 into 1 plus 3 minus h. And for right hand limit, f of 1 plus h, we have to substitute there only, where it is ax square plus bx. You can see the function, I keep it in the same frame better. F of 1 plus h, same approach you will be doing for JEE. For JEE, I have to tell you one more thing, that, okay, let me discuss this first. The way you will answer board paper, I tell you first, then the same sum you have to solve in entrance exam. How to do it, I will explain. So this you simplify, it is going to be 2 minus this get cancelled, all these things getting cancelled, 2, 3, 5 and this 5 get cancelled, so just minus 2h by minus h, and this part will be what? This divided by h. Okay, so you just simplify it, strike h out, 2 equal to, this is going to be, you take constant terms together, a plus b minus 5 plus h into 2a, h we are taking common, 2a plus ha plus b by h, and this thing is limit h tending to 0. But now there is a problem. This kind of problem I have discussed other sessions also. I am telling you, this limit doesn't exist if you cannot make this part is 0. They said that it is differentiable everywhere. So for differentiability, this part has to be 0. For differentiability, that is isn't it? This has to be 0, otherwise the limit on RHS will not exist. So what does this imply? This thing now 2 equal to h 2a hb by h. These two get cancelled. Since h not equal to 0, so this implies 2 equal to 2a plus 0 plus b. So what do you get? 2a plus b equal to 2. Subtract. So a equal to minus 3 and b equal to what? 5 minus a. I got it from this equation. This will be 8. Okay. Now in this sum I got a and b. Nice sum. So you got a and b. Now go back to the original sum. A equal to minus 3 and b equal to 8. So after that we got fx equal to 2x plus 3 and put a and b here. A is minus 3 and b equal to 8. Okay. Now you can easily find the value of f dash 3. ddx of at x equal to 3. So minus 18 plus 8, the value is minus 10. Clear? Understood? Done? The value is minus 10. Now, differentiability this way, this elaborate method you apply for board exams. I will suggest you to do that. But I told you earlier also, if somebody uses advanced method, board has clear instructions. This time it was that student can use any advanced method, you have to give the mark. So what does it mean by advanced method? I will not say advanced method, this is a faster method than this. Here calculating this manner definitely will help you to solve many JEE sums also. Decision making is very difficult without learning this. So you should learn it properly, but in addition I am telling you, when you are answering board MCQ or JEE main paper, you have every right to perform the calculation by using direct differentiation. What is that? So this alternative way I am telling you, what I will say that there, that as it is differentiable at x equal to 1, so a f dash 1 equal to r f dash 1. You only told us limit. But here I will find a f dash 1 by direct differentiation. ddx of here ddx of ax square plus bx at x equal to 1. So this is 2 plus 0 equal to, at x equal to 1, if you differentiate, what's the value of differentiation? 2ax plus b. If you put it, 2a plus b. So you got 2a plus b equal to 2. But you need to get a and b. And then you put here directly, you'll get. What other information can be used that you could do earlier also? What is that? Differentiability at x equal to 1 implies continuity at x equal to 1. Therefore, the function is differentiable differentiability at x equal to 1 means continuity at x equal to 1. So left hand limit at x equal to 1 should be right hand limit at x equal to 1. Left hand limit at x equal to 1 is what? Right hand limit is what? So a plus b equal to 5. This is number 2. Same equation you got. Just solve these two directly. A is coming minus 3. Just solve, subtract. And b equal to 8. So answer you get if you put there x equal to sum is here. Yeah, f dash 3 you get here. You just put those values, you will get the value. Here derivative and just put the value because a and b you got correctly. So f dash 3 will come minus 10 over there. Do I need to do? Same thing, same calculation. Here you did it. Ddx of this thing minus 10. After this, similar calculation. So I am not going to do. Instead, this session I told you that we will be revising whole of differentiation concept. This time we are going to do some problems on direct differentiation. You can recognize this sum. How many of you? If you don't recognize, you do it and then recognize. You have to prove this thing. You start for 1 minute, then I join with you. Just do it. Just do it. You can go by direct differentiation or go by direct differentiation. Differentiating with respect to x, 1 equal to dy by dx log of xy plus y into xy derivative 1 into y plus x dy by dx. It's alright. So this implies 1 equal to, you can put the value of log of xy also. It is x by y. If you like, you can put. Otherwise, just continue. Dy by dx log xy now take the terms free of dy by dx on left side and terms containing dy by dx on right side. So common log xy plus 1, isn't it? So this implies x minus y by x dy by dx xy plus 1. Clear? Understood? Have I got the answer? Check once. No, I haven't got it. Or I have got. How? You just make dy by dx subject to other terms. Okay? Just open the bracket. You got this. X log x plus y plus x. I've chosen some different types of sum to revise it. Normally, in the past sessions, the kind of sums I have discussed, I'm not going to tell you that because those are done by me once. Better you learn. No, better you learn it with me. Sum is done before or doing just now, it doesn't matter. Just do with me, you can do before I complete here. Okay, let us go for next one. This is a very common sum, NCERT sum. This is just to remind you, okay, because this is one of the important sum given in the textbook. Given expression is this, to get dy by dx this thing. What I am doing there, transferring one term on right side, then squaring x square 1 plus y isn't it? So this implies that x square minus y square xy, if you take common, or x plus y clear? Here x cannot be y. If you write as x not equal to y, so what does this imply? This part will be 0. Isn't it? So this implies that y into 1 plus x equal to minus x. Therefore, alright, now required to prove this thing with y equal to, I am writing here, we got y equal to minus x by 1 plus x. So we just need to differentiate once. Do complete. I will wait. Check whether it's coming or not. Yeah, just differentiate. dy by dx 1 plus x whole square minus minus plus x into 1 Alright, done. Now let us go for next problem. Check the sum once. Y into, this is this time not given in textbook, that's why I've chosen this sum to help you to know how to start. This is a trigonometric sum basically. You take, let x cube equal to sine theta both are variables. If you say that no, I'll take a sine theta, a sine theta, not required because the value is less than 1, no, 1 minus this thing given. So this is perfect. We can take that because inside root it is going to be a finite quantity. So this substitution will work nicely if you put. This has to be less than 1. So only sine theta or only cos theta is the appropriate substitution. Okay? Now with this substitution let us work. So this is going to be what? Cos theta plus a into or a into alright, cancel this factor. So this implies cot theta minus phi by 2 equal to cot inverse A. So what does this imply? Theta minus phi 2 cot inverse A. But we are supposed to find derivative. This theta minus phi relation, how does it help? Of course it helps. How? Just you put theta equal to what? Theta equal to, from here, sin inverse x cube. Phi equal to what? Sin inverse y cube. Just put and then differentiate. Theta equal to sin inverse x cube so just differentiate. Derivative is 3x square by root 1 minus x cube whole square. Remember it. Sin inverse x derivative is what? 1 by under root 1 minus x square. Okay? So here x cube. That's why we write the form but derivative multiplied. That's why I did. Here y cube whole square 3y square divided by dx. In a live session, when you are sitting, you practice with me, you will remember many things which you have done before. This is quicker than any other method. That's why this class is being arranged. So now you find dy by dx from here and prove that result is this. Check once. Have you got it already? Just check with dy by dx. Oh, dy by dx only not found out. Yes, we will do it from here. Dy by dx you can find from here. So this implies see, it's coming now. Transfer the side and express dy by dx. 3 getting cancelled. It's a common term. So dy by dx coming to be x square root 1 minus y to the power 6. Alright? You understand this thing. This thing only. So just make the substitution and then differentiate both sides. This sum can be asked in various forms. This is one of the forms I have discussed. Okay? Method is same. One of them will be sin theta, the other one will be sin phi, or cos theta and cos phi. Both will help. Then proceed. Now go for this one. If cos y equal to, just read the sum, and the strategy is my policy. You will start first, then I will put my hand on what till what you have finished. Okay? Try. Check how to do. I hope you have started. Now for this kind of sum, a very common method we are going to follow. You write cos y by cos of a plus y. Dx by dy you find cos of a plus y minus sin y. We are differentiating with respect to y. Cos y, and then derivative of cos of a plus y will be minus sin of a plus y. So this is minus minus plus. So this is sin a cos b minus cos a sin b. Sin a minus b. So you got dx by dy, and that given by sin a by cos square a plus y. Just take the reciprocal because we need to find dy by dx. So dy by dx will be what? Just reciprocally of it. Clear? Understood? These simple manipulations keep in your mind. You will excel in board, you will excel in any exam in this world. But provided you must be very efficient for this kind of manipulation. Okay? Manipulation is very important term in mathematics. If you are good in manipulating these kind of manipulations, then you can manage any sum in this world. Now, there are so many good sums. I'll share the link with you. We'll do. Check the sum. If y into, just read. Before I do, you start from your side. Just check. This is a proving sum. We can make it MCQ also if you like. This sum we can make MCQ at ease. Just option, if this is this, what is the value of this thing? Change a little bit, plus 2 over there and write the options accordingly. Done. So let us answer this one. Go by direct differentiation. If you don't like, transfer it on right side. It's up to you. I am doing by direct differentiation. Differentiating with respect to x. dy by dx half x square plus 1 to the power half minus 1 into 2x log of this function derivative. This will be what? 1 by into its derivative. This is root x square plus 1 Am I clear? Check. I think I have done correctly. Just simple derivative. Product rule here and log rule here. So root x square plus 1 dy by dx xy by root equal to x by root that divide by minus x. Okay, so this implies dy by dx plus you write x minus root over x square plus 1 okay. Just take LCM and add. Check my calculation. Ordinary LCM and addition, nothing else. Cross multiply, and one very interesting thing to see on the right hand side, terms getting cancelled if you take negative sign. Suppose I have written minus sign here, it will be minus, this will be plus, these two get cancelled, cross multiply. So x square plus 1 divided by dx equal to minus 1, and this only they have told you to prove. Just take minus 1 on left side. So once you dare to solve the sum, you can. Okay, there is no doubt about it. Done. I am telling you, student of CBSE board, what they do in class 11 and 12, if they remember all the concept, all kind of sums, normal coursework, 60% ensured in any competitive exam. If you tell me that I know the concept, I can apply it in simple sums, then I will tell you, you go for any competitive, you will excel over there. Understanding is very important. This manipulation, they can give the question various manner, but we have to proceed like this. So many sums I have given, I cannot discuss all the sums here. I will be selective. How to solve this kind of inverse wala sum? Okay, let me start with this one, selecting this one, number 7 here. Okay, inverse advanced formula not there in your syllabus. You have not learned, you are not trained for that. So how to do it? But basic property, sine inverse, sin x is x, it is there. Isn't it? This you all know that it is there. So I'll be targeting that application only. So let me make a substitution. Let, how to answer it in board paper, obviously in school paper also I am telling first. Let 5 to the power x equal to z. 5 to the power x z, no z. 5 to the power x direct tan theta. So RH is going to be what? You can do one thing. Y equal to this is given, find dy by dx. This implies what? Sin y equal to by 1 plus 5 to the power 2x is nothing but 5 to the power x whole square. So RHS will be what? 2 tan theta 1 plus tan square theta. 2 tan theta by 1 plus tan square theta is sin 2 theta, isn't it? This is sin 2 theta. So what have you got here on this assumption? Sin y equal to sin 2 theta. Understood? This is the approach. Now theta is what? Tan inverse 5 to the power x. Anyone can differentiate. Just find dy by dx. Isn't it? Just find dy by dx from here. So dy by dx is tan inverse x is 1 plus x square. 1 plus 5 to the power x whole square into derivative of 5 to the power x. Log 5 by 1 plus 5 to the power 2x. Clear? So this way. I will be showing you just one more sum because this is recap of first sessions. Any one of these. I am targeting targeting this one, this sum. Rest of it you will solve, but by this method. What's the sum? Y equal to this thing. I don't need inverse formula. Sin inverse A plus B is sin inverse X plus sin inverse Y. I don't know. As a board student, no one taught me. But I know sin A plus B form. We'll go for that. This one also you rewrite as sin Y equal to, this is accepted in board answer script. Even the teacher checking your copy, if they find this way you are doing is not matching with the marking scheme, then also you are allowed, to get the full marks. And board also will send you solution this manner. Send the solution to the examiners this way, the way I am showing it here. There is a relation between 5, 12 and 13, the Pythagorean triplet. You take, let 5 by 13 equal to sin alpha and x equal to sin beta. Just put. Or you take this one as cos beta. So this is going to be what? Five by 13 sin alpha, and if 5 by 13 is sin alpha, cos alpha 1 minus 5 by 13 whole square. So this will be 12 by 13. You can easily replace. And this one sin beta. So sin y you got this way. And this you can write sin of, so y equal to alpha plus beta. What is alpha? What is alpha? Alpha you got here. Sin inverse 5 by 13. What is beta? Beta is cos inverse x. Okay, so just put there and differentiate. This is sin inverse 5 by 13 plus what? Cos inverse beta. Just a minute. Yeah. Cos inverse x. So dy by dx will be what? Because derivative of, you can see that derivative of sin inverse constant, it will be 0, and this is minus 1 by root 1 minus x. So got dy by dx is clear. So this way you can do these sums, you practice all these things. Now let me show you some second order derivative problem. You know it, let me remind you. Okay, and this time promise I am going to do different types of sums. Just check this one. Is it really different type? Check. If it is not, then you practice known one only, isn't it? Do start. Finish it before I do it here. y equal to sine of sine x. Prove that d square y by dx square. Second order started. Differentiation of first order differentiation is second order differentiation, you know. So to answer this, you write first order derivative. Cos of sine x into cos x. Agree or not? Agree or not? You should agree, because correct differentiation I did here. Now do one thing, take this one on left side. Okay? And this is what? Cos of sine x. Differentiate again. Just differentiate again. Minus 1 by cos x square. Cos x derivative is minus sine x into dy by dx plus 1 by cos x, and this will be what? Cos of sine x minus sine of sine x into cos x. Clear? Done? So this is sin x by cos square x. You write it this way: 1 by cos x sin x by cos x dy by dx plus clear? Answer not reached yet. But there is no difference between this step and the answer, because you just multiply both sides by cos x, you will get this thing. Okay? So therefore, just multiply both sides by cos x. So tan x dy by dx now take it on left side and see you got the answer here. What they have asked you to prove, you have done it. Okay? This kind of manipulation you must practice. Okay? Understood? Just go for another sum, then you will start solving yourselves. Just let me complete a bit more difficult sum. How to manipulate in second order derivative this kind of sum. The problem is x and y both are given in terms of another variable. That's why I am targeting this sum here. And in the proving term, you see there is nothing about t. So how to start? For this one, you go by ordinary derivative. Go by ordinary differentiation. What is that? From x equal to sin t, you find dx by dt. From y equal to sin pt, you find dy by dt. Done? My first aim will be to get x and y related, to eliminate what? T from these two. How to? Is there any way? Let's see. Let us find dy by dx first. This will be so you put p cos pt by cos t. Cos pt is what? Cos pt is root over, and cos t is what? 1 minus sin square t. Okay, so this implies isn't it? So this implies 1 minus x square dy by dx whole square alright. Now just go for finding derivative again. Differentiating with respect to x, minus 2x dy by dx whole square, and derivative of this thing is what? 2 dy by dx into clear? Now divide both sides by 2y dy by dx, a very common step. No, divide by 2 dy by dx, not 2y dy by dx. I am writing dividing by 2 into dy by dx. So this will be, and this will be, take it on left side, plus, bus, finished. P square y equal to 0 because you have divided by, and you see this is the sum only, no? 1 minus x square d square by dx square plus p square y minus x. Oh my god, why 2? No, this 2 is not there because you have divided by 2 into dy by dx. This get cancelled. Okay, I hope this will help you to start revision work on differentiation. I have tried to remind you the whole concept. Okay, thank you for staying with me.